Hi everyone. Today we're going to continue Chapter 4 for Module 2. And today we're going to discuss isotopes and atomic mass. So last time we talked about protons, neutrons, and electrons, which are subatomic particles. And we also discussed how to determine how many protons, neutrons, and electrons an atom has. Now, what if we have a bunch of different atoms of an element? How do we figure out the mass of that sample of atoms? Because not every atom of an element will have the same mass. So that's where isotopes come in. So isotopes are atoms of the same element, but they have different mass numbers. So they have the same number of protons because remember, protons identify the element. However, those atoms could have different numbers of neutrons, which changes their mass number. So also remember that protons and neutrons have mass and they're in the nucleus. Electrons don't really have mass and they're outside of the nucleus. So when we're thinking about the mass of an atom, we're really talking about the protons and the neutrons. So again, isotopes, we could have two atoms. And let's say we have atom 1 and atom 2. And they're of the same element, so maybe they're both magnesium atoms. But atom 1 might have, let's say, 12 protons and 12 neutrons, and atom 2 has 12 protons but maybe 13 neutrons. So it is possible for different atoms of the same element to have different numbers of neutrons, and those are isotopes. Now, down below, we have a isotopic symbol there, and this symbol allows us to see both the mass number and the atomic number for a particular atom. So we write the element symbol, and then to the lower left, we write the atomic number. So for magnesium, that's 12. And remember, that's also the number of protons. And then above that, we put the mass number, which remember is the number of protons plus neutrons. Okay. Now also remember we can take the difference between the mass number and the atomic number to figure out how many neutrons we have. Okay, so again, isotopes, this is really key. They have the same number of protons but different numbers of neutrons. All right, so let's do a practice problem where we try to determine the number of protons, neutrons, and electrons for different isotopes. And we're going to use these isotope symbols shown below in order to figure out those numbers. All right, so if you want to try this on your own first, feel free, and then you can pause the video. And when you unpause the video, we'll go over this together. Okay, so let's start with oxygen. All right, so according to this isotope symbol here, we have an atomic number of 8 and a mass number of 16. So knowing that information, how many protons does this isotope of oxygen have? 8. It's the same as the atomic number. Now, we can kind of skip ahead and talk about electrons because remember, if we have a neutral atom, the number of protons will equal the number of electrons. So we can already say that there are 8 electrons. But now we have to figure out how many neutrons this isotope has. Because remember, isotopes can have different numbers of neutrons. So in this instance, we're going to use that equation where the number of neutrons is equal to the mass number minus the atomic number. So for the number of neutrons, we subtract 8 from 16, and that will give us 8 neutrons. All right, so not too bad. Now, let's look at P, which stands for phosphorus. I'm just going to erase our values here. All right. So now we're thinking about that isotope of phosphorus. Okay, so remember on the bottom left we have the atomic number, which is 15, and then above that we have the mass number, which is 31. So how many protons does this isotope of phosphorus have? 15. And we can already say, okay, if we have 15 protons, we also have 15 electrons. So easy enough. Now, how many neutrons does this isotope have? So we're going to subtract 15 from 31. And that gives us 16 neutrons. All right. So now let's focus on the last isotope, zinc. So let me just erase some of these numbers here. And we're going to put in values for zinc. So for this isotope of zinc, we have an atomic number of 30 and a mass number of 65. So how many protons does zinc have? 30. And just like we saw before, that's also equal to the number of electrons. So now let's figure out how many neutrons there are. So we're going to take the difference between the mass number 65 and the atomic number 30, and that gives us 35 neutrons. All right. And then here's the solution slide if you need that later. And they don't have the number of electrons listed, but that's the same as the number of protons. So this is the number of protons and electrons in that column. Okay. So now let's focus on an element with different isotopes, such as magnesium. So elements have naturally occurring isotopes, so isotopes that just exist in nature. And magnesium has 3 naturally occurring isotopes. So the first isotope is magnesium 24. So that atom or isotope of magnesium has a mass of 24. There's also magnesium 25, so that has 1 more neutron. And then there's also magnesium 26. So how did scientists figure out that there are these 3 isotopes? Well, there's different ways that you can determine the different isotopes for an element. One way is to use something called a mass spectrometer. And mass spectrometers will separate atoms based on mass. And what you end up with is a graph of mass versus percent abundance. So once the instrument separates the atoms and detects them, they would find that magnesium 24 is the most abundant. So this has a mass of 24. And that has a percent abundance of 78.7. And then magnesium 25 is the least abundant. So that has a relative abundance of about 10%. And then magnesium 26 is slightly more abundant than magnesium 25, and that has a percent abundance of about 11. And so that is exactly what's shown off to the right. We have our magnesium 24 isotope with its percent abundance listed below, and the same for magnesium 25 and magnesium 26. So if you had a sample of magnesium atoms, so let's say we just had a sample of magnesium, and if we could zoom in on all of those atoms, about 78.7% of those atoms would have a mass of 24, or 12 neutrons. And then about 10% of those atoms would have a mass of 25, or 13 neutrons. And then the last remaining 11% would have a mass of 26, or 14 neutrons. So what we'll do is just take a weighted average of all of those masses, and that will equal something called the atomic mass. And that atomic mass for magnesium is 24.31 atomic mass units. And that kind of makes sense. So if our most abundant isotope of magnesium has a mass of 24, then the average mass of a bunch of magnesium atoms should be pretty similar to 24. But it's just slightly more than 24 because of the magnesium 25 and magnesium 26 atoms that exist in every sample. All right. So now on a periodic table, underneath the element symbol, you'll find the atomic mass. So if you were wondering what those numbers are, that's the weighted average of a bunch of magnesium atoms, or whatever element you're looking at. Okay, so in your textbook, there's this handy table, table 4.7, and this summarizes the isotopes of magnesium. So this just kind of walks through the number of protons, number of electrons, and then the mass numbers, which again, you can take the difference and get the number of neutrons. And then it also lists the exact mass of the isotope, which is a little bit less than the rounded number that we have. And then also the percent abundance. Now, you'll also notice that there's a different way to write the isotope symbol. So you can just write the element symbol followed by a dash and the mass number. Some scientists prefer to write the symbol this way because they already can look up the number of protons or the atomic number on the periodic table. So the more important factor is that mass number. Okay, so let's do a learning check. Let's look at the 3 naturally occurring isotopes for carbon. So carbon 12, carbon 13, and carbon 14. And we're going to determine the number of protons, neutrons, and electrons in each of those 3 isotopes. Okay, so what we need to do first is look up the atomic number of carbon. because that will tell us the number of protons and the number of electrons. So let's pull up our periodic table. I've been having some technical difficulties with my iPad, so bear with me here while I pull up the periodic table. Let's see, LMNO P, there it is. All right, so if we're looking at the periodic table, carbon is right here. So that's number 6 on the periodic table of the elements. So that means our atomic number for carbon is 6. All right, so let's write that down. So we could also write a 6 on the bottom left of each symbol down below. But also that atomic number tells us the number of protons, right? So each isotope has the same number of protons, because remember, protons identify the element. And remember, electrons are equal to the number of protons because we're assuming we have neutral atoms. So we could just write in 6 for each of the electrons. So now we have to figure out the number of neutrons. So remember, we take the mass number and subtract the atomic number. So we're just taking the difference between those two values. All right, so 12 minus 6 for our first isotope gives us 6 neutrons. 13 minus 6 gives us 7 neutrons for the second isotope. And then 14, not 13. 14 minus 6 gives us 8 neutrons for the last isotope. So again, this is just to highlight that if you have isotopes of the same element, they'll all have the same number of protons, but they just have a different number of neutrons. And that will also give the isotopes different mass numbers. All right, and here's the solution slide. So let's look at isotopes in a slightly different way. What if we're told the number of protons, neutrons, and electrons, and we have to figure out what the isotope is? So let's do the first one together, and then you can work on B and C on your own. So in problem A, we're told that our isotope has 8 protons, 8 neutrons, and 8 electrons. So the key thing here is the number of protons, because that is also equal to the atomic number. All right, so let's look up on a periodic table which element has 8 protons. And hopefully the periodic table pops up. Yay, okay. So if we look at the atomic numbers, which remember are in the upper right-hand or left-hand corner, we can kind of scan through and find element number 8, and that is oxygen. All right, so now going back to our PowerPoint. So now we know that in part A, we have an isotope of oxygen. And it has 8 protons, that's its atomic number. And now we need to figure out its mass number. And remember, the mass number is the number of protons plus the number of neutrons. So 8 plus 8 is equal to 16. So that's our mass number. So for this problem, we can kind of ignore the number of electrons because that didn't really give us much information other than telling us it was a neutral atom. So now I encourage you to pause the video and try to figure out which isotopes you have for part B and part C. And then when you unpause the video, we'll go over that together. Okay, so let's figure out what we have in part B, and I'll use a different marker color here. All right, so we have something with 17 protons. So let's look up number 17 on the periodic table. So let's see, scanning through. Number 17 is chlorine. Okay, so let's go back. So we know that we have a chlorine isotope, and every atom of chlorine has 17 protons. And now we have to figure out the number, or the mass number. So we're going to add the number of protons to the number of neutrons. So 17 plus 20. So that gives 37. Okay, so that's chlorine 37. That's our isotope. All right, so now for the last one, part C. So we have something with 47 protons. So let's look up number 47 on the periodic table. Let's see, so 37, 38, go across, 47. So that is silver, Ag. Okay, so we have an isotope of silver, and every atom of silver has 47 protons, but we need to figure out the mass number for this particular isotope. So 47 plus 60, let's see, that is 107. Okay, so not too bad, hopefully. Hopefully this is good practice. All right, and then here are these solutions. So earlier we talked about atomic mass, and there is a way to calculate atomic mass, so we're going to go over that. So again, atomic mass is the weighted average of all naturally occurring isotopes of that element. And again, atomic mass is the number on the periodic table below the chemical symbol. So it's usually listed right below that symbol for the element. Now, chlorine has only two naturally occurring isotopes, one with a mass of 35 and one with a mass of 37. And scientists were able to determine that chlorine 35 is the more abundant isotope. Its percent abundance is about 75% or 76%. And chlorine 37 has an abundance of about 24%. All right, so on the periodic table, we can see that the atomic mass is 35.45 AMU, or atomic mass units. And that makes sense because the more abundant isotope is chlorine 35, so the atomic mass is a little closer to 35. But how do we actually calculate that atomic mass? So to calculate that atomic mass, we're going to use the percent abundance of each isotope, and we're going to multiply that percent abundance by the atomic mass of the isotope. And then we take the sum of the total mass of all isotopes. All right, so atomic mass is equal to, so we're going to take the percent abundance of isotope 1, let's say, and multiply that by the mass of isotope 1. And then we're going to add the percent abundance of isotope 2 times the mass of isotope 2. And if you had more than 2 isotopes, you would just keep going. So you would add the percent abundance of isotope 3 times the mass of isotope 3, etc. So you just keep going. All right. So not too bad. We're just taking the abundance of one isotope and multiplying it by its mass. And then we're doing the same thing for all of the isotopes and then just adding all of those values together. So for chlorine, for instance, the atomic mass of chlorine is equal to the mass of chlorine 35 times the percent abundance of chlorine 35. But we actually want this in decimal form. We don't want this in as a percent. So we're going to divide the percent by 100. So that's a really key point here. So we're taking that percent abundance and dividing it by 100. And then we do the same thing for chlorine 37. We take the mass of chlorine 37 and we multiply that by the percent abundance divided by 100. So down below we have a little table kind of summarizing this calculation. So remember when we saw the summary table for magnesium isotopes, it listed the exact mass of the isotope. So we're going to use the exact mass here as well for each isotope. So the exact mass of chlorine 35 is actually a little bit less than 35. It's 34.97. And then we're going to multiply that by the percent abundance, which we said was 75.76. And we're just going to divide that by 100 so that it's decimal instead of a percentage. So that's going to give us the contribution to the atomic mass. So for chlorine 35, that's 26.49 atomic mass units. And you can plug this into your calculator just to double check that you get the same thing. And then chlorine 37 has an exact mass of 36.97, so it's a little bit less than 37. And then again, we're going to multiply that by the percent abundance, which we said was 24.24, and we'll divide it by 100. And that gives us 8.962 AMU. So now we just have to add those two values together, and that gives us the atomic mass of chlorine, which is 35.45. So what's really great about these calculations is you can always double check your work by looking on the periodic table, because you should get the exact same value that the periodic table lists. So that's always nice. You already have the answer. You'll just have to prove that you know how to calculate the atomic mass. All right, so let's look at the atomic masses of some other elements as well as their isotopes. So in table 4.8, we have a few different elements listed. So for instance, lithium has two naturally occurring isotopes, lithium-6 and lithium-7. And the most abundant isotope is lithium-7. And then the atomic mass of lithium is 6.941, which is really close to 7. So that makes sense given that lithium-7 is the more abundant isotope. And then we already saw that carbon has 3 naturally occurring isotopes. And the most abundant isotope is carbon-12. And so the atomic mass of carbon is actually 12.01, which is really close to the most abundant isotope mass. Now, you'll notice that fluorine, if we jump down a little bit, has only one naturally occurring isotope, fluorine-19. And its mass is exactly 19 atomic mass units. So sometimes some atoms will just have one isotope. That's also something that happens, I guess. Now, some atoms can have, or some elements can have multiple isotopes. So for instance, sulfur has 4 naturally occurring isotopes. So that's quite a bit. Now, the most abundant isotope is sulfur 32, and we can see that the mass is pretty close to 32 there. So anyway, this is just something to think about if you're ever doing calculations for atomic mass. You can also predict your answer based on the most abundant isotope. Okay, so let's actually practice using that equation for calculating atomic mass. So gallium is an element that's found in lasers used in compact disc players, so CD players. CDs are actually kind of outdated now, aren't they? But if you still have a CD player, like in your car or something, gallium is an element that's found in the lasers in those devices. So in a sample of gallium, there is 60.1% of gallium-69, and the exact mass for that isotope is given. And then there's 39.9% of gallium-71, and the atomic mass, or the exact mass, is given there. So 70.925. So what is the atomic mass of gallium? All right, so if you want to try this on your own first, feel free to pause the video, and then when you unpause the video, we'll go over it together. All right. So remember our equation for atomic mass. We're going to take the mass of isotope 1 and multiply it by the percent abundance of isotope 1 and divide that by 100. And then we're going to add the mass of the second isotope multiplied by its percent abundance divided by 100. And in this case, we only have 2 isotopes, so it works out. We don't have to add any further isotopes there. Okay, so let's do that. So the mass of, let's start with gallium-69. So the exact mass is 68.926 AMU, atomic mass units. And we're going to multiply that by the percentage, 60.1 over 100. And we'll do the same thing for isotope 2. So the exact mass of gallium-71 is 70.925 AMU. And then the percentage is 39.9 over 100. Okay, so I'm going to plug this into my calculator. Let's see what we get for the first part. So let's see, let's take 60.1, divide that by 100, and then multiply that by 68.926. So I get 41.42 AMU. And then for the second part of our calculation, let's see, 39.9 divided by 100 times 70.925. So I get 28.30. All right, so now let's add those two values together. And we get 69.72 AMU. All right, so that is our atomic mass of gallium. But let's double check. Let's look at the periodic table and make sure we have the same answer. All right, so gallium is number 31 on the periodic table, and the atomic mass is 69.72. Well, they added a 3 on there, but we only had 4 sig figs, so. All right. So that checks out. Awesome. And then here are the solution slides. So now on Canvas, I posted an activity that you can go through. It's called the Subatomic Particles and Isotopes Worksheet. And this will give you more practice with protons, neutrons, electrons, and isotopes. And there's a key at the very end of the worksheet so you can double check that you got the right answers. All right, so in the next video, we're going to finish up Module 2. So I will see you then.